Hello everyone, today we are going to solve a very interesting problem, search in a 2D matrix. Okay, so it seems to be very easy problem, but let's understand it. Write an efficient algorithm that search a value target in an M and cross integer matrix. This matrix has following property. Integer in each row are sorted from left to right, and the first integer in each row is greater than the last integer of the previous row. So the first integer in each row, first integer is this, is uh, greater than the last integer in the previous row. Okay, so ये इससे बड़ा होगा. That means I will let you know, like that means if I have a 1 3 5 7 10 11, that means this 10 is always greater than 7. This 23 will be 20. Okay, so basically we have to find one target in this matrix. So how we are going to do this? This problem have multiple solution, and depending on the time complexity and the space complexity, we have to give our best solution. Okay, so let's start with the first solution. What will the first solution of this problem? As soon as you see this problem, you can give the first solution as iterate in mn cross matrix and give it the target value. So we are using two loops, one loop from 0 to m and second loop from 0 to n. If matrix ij equals to target, then return true. We have to return true or false only. Return true, otherwise return false. Okay, that's the simple snippet of the first solution. So we have to do this, and this will be the time complexity of m cross n, and it is the worst time complexity. And interviewer will never be happy of this solution, as it is given that the row is sorted. So how we can do the next optimization? It would be how we can use this. If row is sorted, how we can use this? Basically we can go through each row. We can go through each row and apply binary search on each row. Binary search on each row. But why do we need to apply binary search on each row? We can do more better thing. We can find the condition if our target is greater than 1 or is smaller than last element, then we are going to apply binary search. So that we need to apply binary search only once. Okay, so what I'm trying to say is, you can go first loop from 0 to m in to each row. You have to go and see if your first element of the that row matrix I0 is equals to, like not equals to, is like greater than equals to target, and it's the last element that can be matrix I n minus 1 less than equals to target. In that case we can use simple binary search and check do we find is we find the target or not. So the time complexity of this solution will be going to like of m plus this will take n log n time. So the time complexity is n log n, m plus log n, which is far better than this. Okay, so but let's try to see the next point we have right now is the first integer of each row is greater than the last integer of the previous row. So can we use it in certain way? Yes, we can. How we can use this is, let's see, write the first element 1, first row is 1 3 5 7. Write second row 10 11 16 20 and 23 30 34 60. So basically, if we see that, then it is a sorted list. It is a sorted list. So what we can do, we can apply binary search on this sorted list, and the length of this list is m plus n. So the time complexity will be log of m plus n, isn't it? It's very simple. Now the only task remaining for us is to find the indices. How we can find the indices? To find the indices, we can use simply, let's find the indices of the first row. First row is 0 comma 0, that is 0 comma 1, 0 comma 2, and 0 comma 3. And here is the position of this element is you can say 0, 1, 2, 3. Here it is 4, but here the position is 1 comma 1. Here it is 1 comma 2. I'm sorry, 1 comma 0, 1 comma 2, 1 comma 3, and here it is 5, 6, 7. So how we are going to do this? So basically we can do this simply. Here we can use the length of row is, let's say, m. Okay, length of row is m. This index will be m into n minus 1. This index will be 0. Okay, and all the indexes we can find using the formula. The row number m into their row number plus column number Okay, so this is how we can solve this problem. So let's see the solution. So this is the solution of our question. We can first find the number of rows, then number of columns, then we are going to say low. Let's say low is our 0 and high is our the end of the sorted list, which will be m into n minus 1. Then we are going to find the mid will be low plus high minus low divided by 2. Then how we can find the row number will be found by mid divided by m, and the column number will be found by taking the its remainder. Okay, and if we find that element, then what we are going to do, we are going to return it true. This true. Otherwise, if it is greater than target, so we need to reduce our high from mid high to mid minus 1. If it is if our matrix element is less than target, then we have to increase our low to mid plus 1. And if we are not able to find in the matrix, then we are going to return the false. So what is the time complexity of this solution? Time complexity will be of log of m plus n, which is far efficient than our first solution and the second solution. If you have any doubt, you can ping me in the comment section. Thanks for watching.